So the charge labs tapes, our main goals were to learn how to automate the process of calculating the electric field produced by a charged particle, which is usually done by hand but can be tedious, and instead use a computational model in GlowScript. We displayed the electric field in multiple locations to examine its 3D pattern, and we did this using a charged piece of tape as our base. So what are some key concepts that we need in order to do this investigation? So some of the concepts are we've already seen in Physics 1, such as Newton's second law, just change of momentum over time, and gravitational force, which we use 9.8, and we use the mass of the object. This will be used later in calculations. And then one that we also saw last class, but has become more relevant now with electric fields, and that is electric force, Coulomb's law. We see Coulomb's constant down here. And the R vector here represents the difference between the point of observation and the source. So what is the procedure? So we cut two pieces of tape of equal length and note down what this value is of the length. Well, we can also measure the width of this tape, which will be useful later. And we create a U shape by placing one piece of tape on the table and another on top of the piece of tape, but not stuck all the way, like a little bit up, so we can rip it off. So we rip this off, and that's how we charge the tape. We repeat this twice, so we end up with two pieces of tape. The first one can be A, and the first one is B. Then we will place B on top of two objects of the same height and hold tape A below us, like parallel as we can with both hands. And we move tape A closer to B until it almost floats near B, and we measure what this distance is. So some calculations. First, we need some measurements. So the tape length we measured to be 0.18 meters, 18, yeah, centimeters, and the tape width was 0.019 meters. With this, we calculated the surface area and also the distance between tapes. So when it was floating, we calculated it to be 0.025 meters. So the first thing we calculate is the number of atoms. We do that by dividing surface area over area of atom, which we will use in later calculations. And then the weight of the tape. So this is just the mass that we calculated times its times the force of gravity, 9.8. Then we continue. We want to find the force of gravity on U tape is what we calculated just earlier. It's just the weight. We just put that in vector form, going in the negative y-hat direction. The charge of U tape, we have this is the main formula we're using. This is just the superstition of electric field, so F net, and we're assuming that Q1 is equal to Q2. So we found that to be plus 1.11 times 10 to the negative 8. So we see it's positively charged. And then we calculated the deficient electrons and the ratio of deficient electrons to atoms. So now we compare using the computational model. So this is the part we put in all the constants, the mass, the area, all of the things that we measured earlier. And then we set up some calculations like the weight using G, which we established to be 9.8. So just laying out the constants in the code to use later in these calculations. So we have some print outputs so the model can tell us what the results are. But the important parts of calculations, we're using the formula we learned in class, using the distance between two dipoles. And the distance is also what we calculated earlier. And yes, we also use once we have the number of atoms and electrons for the ratio of deficient electrons. So just putting in the formulas that you saw earlier, but in computational form. And we'll discuss the main results later, but some things to discuss are, for example, static equilibrium. So because for the tape to float, the net force had to be 0. Therefore, the force through gravity is equal in magnitude to the electric force held by tape on suspended tape. So the A on B. The tape becomes positively charged. This is what leads to electron deficiency. The electrons are leaving the tape. But we will see maybe a few discrepancies between the model and calculations. So here are some possible errors. So what if? So what if the electrons were negatively charged and protons were positively charged? What would change? Would it still be positively charged? So the electric fields for the object would switch because the electrons and protons switch. So the tape would now be negatively charged. But to our eyes, there would be no change. Because both tapes are now negatively charged instead of positively, they still repel each other. So we are going to be observing the same results, although on a physical level, the electric fields have changed. And why? So let's compare the estimated value and the charge you get to the experimental value and see which model is more accurate. So our number was actually similar. The computational model showed that the charge of the tape was plus 1.106797. And then through calculations, it was found to be plus 1.11. So